Now see children, today's our topic is exploring geometrical figures, 8th class, exercise 1. Name 5 pairs of congruent objects you use daily. Footwear, it may be slippers and they may be shoes, whatever it is, footwear. Bangles, eyeglasses, fans. Okay, these things are very useful things. Tables of your school, benches, milk bread pieces, ribbons, earrings, pencils, geometry boxes, pens, so many are there. Okay. Now see children, next question. Draw 2 congruent figures. Are they similar? Explain. And the second question, take 2 similar shapes. If you slide, rotate or flip one of them, does the similarity remain? Let us take 2 triangles, triangle ABC and triangle PQR. So here I take triangle ABC and triangle PQR. Here let us assume that length of BC A, length of sides here BC equal to A, AC equal to B and AB equal to C. In the same way here also. Length of QRA, length of PRB, length of PQC. Why? Because we have to take here 2 congruent figures. So we have to explain whether they are similar or not. Okay. So I am taking 2 triangles with the same congruent sizes, congruent shapes. That means their corresponding sides are equal and the corresponding angles are also equal. Now here BC is equal to QR is equal to A, first corresponding pair. Second, AC equal to B, PR is equal to also B. AB is equal to PQ is equal to C. Both are same in length. Okay, so here the corresponding sides are same in length. And angles also. Angle B is equal to angle Q, angle C is equal to angle R, and angle A equal to angle P. So these 2 triangles will be congruent by which property? By side congruency criteria. Already we learned these criteria in 7th class. Okay. So we can say that triangle ABC is congruent to triangle PQR. So that's why they must be similar. Okay. Now, second question. Take 2 similar shapes. If you slide, rotate or flip one of them, does the similarity remain? Let us see. Here 2 similar triangles I take actually. 2 similar triangles. Similar triangles means, so here they have the same shape but different sizes. This one is small and this one is big. Take this. Yes. Once again say this. So I moved this first small triangle from this point to this point. Okay. Does it change its shape? No. The same way that also. Okay. Once again here. So like this. So that doesn't change their similarity. So similarities remain same. Now next, rotation. So for rotation, two triangles ABC, and here also it is also ABC actually. Now rotate this in this way. fully one rotation, does it changes its similarity? No. Here also take this one. Full rotation, take a full rotation here, children, like this. Does it change its similarity? No. Let's take the similar. So take this again. So the full rotation takes place. The change remains same. The similarity doesn't change. Okay, children. So next, flip. So if we flip like this, does it change the similarity? No. Okay, that means this its mirror images. So here this line, red line treated as a mirror. Then once again here, if you flip like this, does it change its similarity? No. Okay, and next in this also, once again, if you flip like this, is it changes its similarity? No. So it will be remain same. So that's why while throwing rotation or throw rotation, throw flip, their similarity doesn't change. Okay. So now let us see the next question. If triangle ABC is congruent to triangle NMO, name the congruent angles and sides. Very simple question, children. So here given triangles are ABC and NMC. So by current congruent triangles, we know that their corresponding sides are equal. That means here AB is equal to MN and BC is equal to MO and AC is equal to NO. Okay, children. So the corresponding sides are equal. AB equal to NM, BC equal to MO and CA is equal to NO. So in the similar way, the angles also. Angle A is equal to angle N. Okay, angle A is equal to angle N. And also angle B is equal to angle M. And angle C is equal to angle O. Okay, so that's why in this way we can write their components, corresponding components. Okay, corresponding sides and corresponding angles. So already they given congruent, that's why we are equating that, or we are equated that congruent, already congruent angles and congruent corresponding sides. So therefore we can say triangle ABC is congruent triangle NM. Okay. So this is actually by SSS congruency. Whether the following statements true, explain reason. So in that one, first, two squares of slides, two squares of side 3 cm each, and one of them rotated through 45 degrees are congruent. Okay, two squares are there. One is normal in position, but another is rotated through an angle of 45 degrees. Can you say those two squares are congruent? Next question. Any two right angle triangles with hypotenuse 5 cm are congruent. Two right angles are there and they are having the common hypotenuse of length 5 cm. Can you say they are congruent? Let us see. Next, third question. Any two circles of radius 4 cm are congruent. two circles having the same radius. Can you say those are congruent? Is it true or false? You will decide. Fourth question. Two equilateral triangles of side 4 cm each but labeled as triangle ABC, triangle LHN are not congruent. They are given two equilateral triangles of each side 4 cm and one is ABC and other is LHN. They are not congruent. Is it true or false? Let us see. Mirror image of polygon congruent to the original. Okay. This statement, whether it is true or false, let us see one by one. Listen now. Two squares of side 3 cm each and one of them rotate through 45 degrees are congruent. So here it is first given normal square, it is its own position. If it is rotated through 45 degrees, then is it congruent to first one? Yes. Why? Because here their corresponding angles are doesn't change and their corresponding sides are also doesn't change. Just this position is it rotated just 45 degrees. Okay, but the shape and size doesn't change. That's why the given statement is true. Okay, children. Now next, any two right angle triangles with hypotenuse 5 cm are congruent. He is saying any two right angles which are having the same hypotenuse, that is 5 cm, are congruent. Can you say is it true? So I am taking one right angle triangle with 3 as a base, 4 as a height, whereas here 4 as a base, that is a 3. Can you say these two triangles are congruent? The same hypotenuse? No. Why? Because their corresponding sides, here 3 and here 4, here 4 and here 3. Irrespective of triangle, angle is equal, but here their corresponding sides are not equal. So that's why the statement is false. Okay, next. Any two circles of radius 4 cm are congruent. So here first circle of radius 4 cm, second circle is also 4 cm. Can you say these two are congruent? Yes, they are same in shape and size also same. Here their shapes are same and size are also same. Just they are coincide with each other also. If you move this first circle on to this second circle, it is exactly coincide with this second circle. That's why we can say these two are congruent. Yes, it's true. Okay, children. Now, two equilateral angles of side 4 cm each, but labeled as triangle ABC, triangle LHN are not congruent. Here, both are same equilateral angle, both are having the same side, but label is different. Can you say they are not congruent in that case? Here ABC equilateral triangle of having the same sides of length 4 cm, and here also LHN is the other equilateral angle of length of side 4 cm each. So can you say these two are congruent? Yes, but definitely they are congruent, but they are given as not congruent. How we can say these two are congruent? Again, same procedure. AB is equal to LH, corresponding sides are equal. Here BC is equal to HN, AC equal to LN, and anyhow the each and every angle is equal to 60 degrees. So that's why angle A is equal to angle L is equal to 60, angle B equal to angle H is equal to 60, angle C is equal to angle N is equal to 60. So that's why the given statement is wrong. So false. Now next, mirror image of polygon congruent to the original. Is it true? Mirror image of a polygon. I am taking one polygon here square. This is just like treated as a mirror, okay, and its image. So can you say these two are congruent? Yes, by this way we can say congruent. So congruency means the corresponding sides and their corresponding angles must be equal. And moreover, if you put on one object to the another, the edges must be coincide. Okay, so that's why we can say those two objects must be congruent. So in the similar way we can say here, say this once again, isn't it? Okay, exactly coincide with that, so true. Now one more important sum here. Standing at 5 meters from a vertical pole of height 3 meters, Sudha observed a building at a back of the pillar. The tip of the pillar is in line with the top of the building. If the distance between the pillar and the building is 10 meters, estimate the height of the building. The height of the Sudha neglected here. Okay, so let us see the figure here. Solution. See children, here Sudha observing the height of the building behind a pillar, and the tip of the tip or top of the pole is on the line of the top of the building. Okay children. Now here also given the height of the pillar or pole is 3 meters, and the height of the building that we have to need, that only we have to need needed value. We have to find that value. And also given the distance between the Sudha and the pillar is 5 meters, and the distance between the building and the pole or pillar is 10 meters. Okay, so by which way can we solve these two? Simple children, by using the scale factor of the proportional. Okay, here two triangles are formed. One is with pole and other is with the what? Building. Okay, so here Sudha's height is not considered, that's why I am taking only one eye figure. So it just with this eye she is observing the tip of the pole and simultaneously top of the building. Okay, so that's why here actually they formed two right angle triangles. Okay, so one is Sudha's eye and with the help of this building, and Sudha's eye and this pole. Okay, so these two are said to be similar, and moreover we can compare these two by using the proportion. Let us see one by one. Height of the building divided by height of the pole. Okay, the ratio of these two heights is must be equal to distance of the building from Sudha and distance of the pole from Sudha. Okay, actually distance between the pole and the building and divided by the distance of the pole from the Sudha. Okay, so by this ratio we can easily find the height of the building. Okay children, we have to write like this compulsory. Okay, now here height of the building is taken as h and height of the pole is taken as 3. Okay, and is equal to the distance of the building from Sudha. Actually they are given the distance from the pole to the eye of the Sudha is 5 meters. Okay children, and the distance from the pole to the building is 10 meters. So the total distance from the Sudha's position to the building is 8 plus 10, 15 meters. That's why I wrote here 15 divided by distance of the from Sudha. Okay, that is pole. Okay, pole from the Sudha is 5. That is, here we are comparing these two triangles by using this formula. Okay, so then we get h by 3 is equal to 15 by 5. And the next step, take this 3 on right side, then h is equal to 3 into 15 by 5. By cancellation we get 5 1s are 5 3s are 3 3s are 9. That is h is equal to 9 meters. Okay children, we got the ultimate value of height of the building is 9 meters. Okay children, so very important, practice well. Now next, one more important, it is depending upon the drawing. Draw a quadrilateral of any measurements. Construct a dilation of scale factor 3. Measure their corresponding sides and verify whether they are similar. Okay children, actually here scale factor is 3. I am taking here one a rectangle like this. Okay. 1 meter or 1 centimeter width or breadth and 2 centimeter length. Okay, so here actually it is emerged or it is with respect to a center bow. Okay, let us see the figure later. Here we have to take this factor formula. So the new rectangle, okay, after dilation means what? Actually dilation means the stretched out some figure to the other. That means we have to maximize the figure in all the directions. Okay, so that is actually dilation, stretched out, or it already stretched out, then we have to compress to its original position also. But here we have to stretch it out. That means we have to make this ABCD rectangle into the bigger structure. Okay, we have to stretch it out. Okay, now by using the scale factor 3. So here the original sizes must be multiplied with 3. Okay, now let us see how the dilation is. Now I am taking graph here, x-axis, y-axis, origin, O. Interesting point. Here I am taking 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 9, and 1, 2, 3, 4, 5, 6, 7 and vertically up to 7. Now see this children. First I take a rectangle, and which is emerged from the, or which is with respect to of the center O. Okay. Now to dilate this figure, dilation of this figure, we have to take the actually scale here. Already we have 2 units, so that's why we have to multiply 2 with 3. That is 3 into 2, we actually get 6, and also multiply 1 by 3. Why? Because here scale factor is 1. Okay, that's why here the length becomes 6 units and the breadth becomes 3 units. So that's why we have to start the drawing arcs with the help of compass at this position 3, 3. Okay, at this position. Okay, let us see. Like this. Let us draw at here, here, here. First you take the 3, 3, and then 6. That means to add or take the measure of 6 units from here. 1, 2, 3, 4, 5, 6. Okay, till here you have to draw a compass. You have to draw an arc with the help of compass, and again here how many units? Already we have here 1 unit. Just for your understanding, actually 2 units is enough, but for our understanding purpose I am taking that more units. Actually 3 units is enough. For our understanding purpose I took 1 more unit. Okay, so actually till here okay. Okay, you just draw the arc at here only, but for our understanding purpose I took 1 more unit. So after drawing 4 arcs, join them like this. So after completion of the figure, this rectangle is stretched out A dash, B dash, C dash, D dash. It looks like a somewhat bigger. Okay, like this. Okay, children. I hope you will understand this figure very neatly. Now, like this, we have to draw the dilation of the face. Okay. In the next video, we will see some more important sums.